Hey there, grade nines. Today we are going to go over lesson 1.2, where we are talking about square roots of non-perfect squares. So a lot of this is going to be estimation, but we're still going to kind of work on it. So let's say, for example, we want to try to find the square root of 7.5. All right. One thing that we can do is we can know that we would have a number line. So let's see if we go something like 3, 4, 5, 6, 7, 8. Let's go 9. I know, so if these are my my squares, I know that my square root for this is going to be 2. I know that my square root for this is going to be 3. And what I'm looking for is 7.5. I'm looking for the square root of 7.5. So I know that it's going to be in between 2 and 3, and I can somewhat guess, like somewhere in the middle of this is going to be somewhere around here. This is going to be about 2.5. Okay, that'll give me kind of a general idea. I'm going to guess it's going to be around like 2.7 or something like that. Okay, what I can actually do is I can take my calculator and I can go 7.5 square root. And I'm going to get kind of a long number. It'll be like 2.7386127888. And then it might stop. Some of you might have more digits, some of you might have less. But what we're actually noticing is that it's not showing that it's going to repeat, and it doesn't seem that it's going to end. So if I take that 2.7386127888 times it by itself, or square it, I'm going to get something like 7.500000003. Okay, so what we would actually say is 2.7 would be kind of an approximation of the square root. All right, so I've got some examples that I'm going to put on the board, and then we're going to try to kind of work through them. Okay. I'll just erase this first before I put up the screen. All right, so here we go. So what we can do is we can actually try to use benchmarks. All right, so that's kind of what's going on here. So we have the first question here. So we have A. Okay, I'll come to the other side, sorry. It's asking, what's the square root of 8 over 5? Well, what's something close that we know? Okay, what's something close that we know? We know that we can find the square root of 9 over 4. How do we know that? Because we know that 9 is a perfect square, we know that 4 is a perfect square. So we have to try to remember what all of our perfect squares are. And these two numbers are the closest to these two. Okay, so when we do that, we can say that the square root of 9 over 4 is 3 over 2. Okay? So we can say that roughly 8 over 5 is going to be close to the square root of 3 over 2. Okay? So then we look at kind of what's going on, for B. So they move to B, so we have 3 over 10. Okay, so these are kind of the solutions that they're coming up with. So here when we have a number line, so we had 3 over 10 written as a decimal of 0.3. So we're essentially looking for the square root of 0.3. All right? So what do? They say, okay, well, we know what the square root of 0.25 is, or 25. Okay, the square root of 25 is 0.5. The square root of 0.36 is 0.6, or the square root of 36 is 6. But all we're doing is we're adding a decimal before it all. But when we're squaring it, it's like the square root of 0.6 is not going to become 3.6 because we're multiplying a decimal by a decimal, so that decimal is going to become smaller. So 0.6 is bigger than 0.36. Okay, so we're looking for 0.3, which is almost, when you look at it, right in the middle. Okay, so you could guess that the square root of 0.3 is going to be somewhere around between 0.5 and 0.6. So I'm guessing right in the middle, I'm going to get 0.55. And that's what they end up saying. So when we go down, okay, we're actually saying that it's close to 0.55, and when they square it, they get something close, 0.3025. Okay, so they're actually pretty close. In the next one, they're trying to find the square root of 3 over 7. All right. So we know that on our number line, it's a little bit over half. So half would be right here. Okay. So we know there's going to be close to 0.49 because we know that that's already a perfect square where we have 0.7. So we're estimating that the square root of 30, or the square root of 3 over 7 is going to be close to 0.7. So we're doing a lot of estimation, and we're just trying to find ones that seem to work. Okay. The last one that they did, so they have the square root of 19 over 6 and they used a calculator, so they end up getting 1.87. So those are some of the methods that you're able to use. So we've got number lines, we've got references, we've got calculator. Okay, so we're trying to use or proximity. Okay, so these are kind of the methods that we're using, that they're talking about. So the first one that they're talking about is just saying, all right, I know that this, for example, if we're looking for something between 10 and 11, okay, what the square root might be. So we're saying that we know that the square root of 10 is 10 squared, which equals, or number with the square root of 10 is 100. Number with the square root of 11 is 121. So if we have any number that's between, or any area of a square that's between 100 and 121, the number is going to lie in between 10 and 11. Okay, it has to. It can't be outside of those two numbers. Okay, so if we look at, for example, so they're saying a decimal between 100 and 121 is 105.6. Okay, so we know that the square root of 125.6 is going to be somewhere in between here. So they use a calculator to check, and they get this long number. So the decimal 105.6 is one correct answer for what can be in between. All right. Method 2 is, so they're saying one decimal between 10 and 11 is 10.4. But now what they're going to do is they're going to square it. Okay, so 10.4 times 10.4 gives you 108.16. So the square root of 108.16 is technically between 10 and 11. Then they can use a calculator to check. The last method that they are doing is they're actually applying it with Pythagoras' theorem. So you're going to get some questions like this. Okay, so if we have this, for example, this question here, I'll move it up a little bit more. Okay, so we have 6.5 and 1.5, and then we have our hypotenuse r. So as a reminder, we're going a squared plus b squared equals c squared. So if we square this, 6.5 times 6.5, and you can estimate it, but you can also use a calculator, times, or added to 1.5 plus 1.5. So if I go over to the other side, we actually have the solution. So we have 6.5 squared plus 1.5 squared, which gives us 42.25 plus 2.25. We add those together, we get 44.5. Okay, and then they actually go through and solve for the rest of it. So then they find that the square root of 44.5 is between, so when they're looking at it, they're basically saying, okay, 44.5 is between which two perfect squares? It's between 36 and 49. But 44.5 is closer to 49 than it is to 36. So it has to be above 6.5, okay? Because the square root of this is 6, and of that is 7. But it's closer to 7. So it has to be higher than 6.5. So they're estimating that the square root of 44.5 is about 6.7. Okay, if you were to put it on a number line, that seems to be fairly accurate. Okay, then what they actually do is they go and they calculate it. They use a calculator, and they end up getting 6.67, which is close because you'd round it to 6.7 to actually figure out the side length of the hypotenuse. All right. Most of this stuff should be a refresher from last class, or from last year, sorry, with the exception of maybe using it with decimals. All right. So, if you have any questions, bring your questions to Zoom. What we're going to do is I'm going to give you some time to do some work. I'll give you some questions to work or to practice everything that I just talked about, and then bring those questions to Zoom, and I can help you out with them. All right. Once again, if you need to get a hold of me, you can ask questions through Google Hangouts. Try to avoid sending emails. Google Hangouts is just faster. If we need to, we can just set up a one-to-one or a small group Zoom session. All right. Good luck.